Hi, it's me again, and I think this video is a little bit, you will get in the internet a little sooner. I just released one and I got a few comments and stuff like this, and I just want to, and people seem to have a hard time to understand, when I'm saying about, we can separate and we can literally release energy and stuff like this. And I know, I believe I find out why the people don't quite understand what I'm saying. I think people think a magnet, this is a round magnet, a resonating magnet. I use them just for play because they're kind of neat. And this is a motor magnet into a scooter, electric scooter, a very strong magnet. And everybody really think the field around a magnet, that's south, that's north, and it should be a field going like this on each side in all direction. But it's wrong. The understanding of a magnet is so misunderstood. The only way when you put a magnet in liquid and you put ferrite dust or filing dust, right, it will make the field around and you feel connect itself. Well, the only reason the field connect itself is you literally give him all the material to build the bridges. It's like having two people across the, each of the company is each side of the river, right? You can have all the power, all the tools, everything up. If you don't have the iron beam, you ain't going to make that bridge, right? Both have to have the same amount of material to be able to bridge the two sides, or you're going to be standing there for the for the rest of your life. So this is how a magnet works. Everybody think a magnet, it's a live field around it and blah blah blah. It's totally false. The field do not connect as I'm holding this magnet. I don't have enough iron in me to make the connection. So therefore the field stay open. Now if I produce this magnet, I don't need a plastic platter, right? And you put liquid ferrites in it. When you put the magnet right on the liquid ferrite, what the liquid ferrite does, it makes all those spikes, right? Very, very big spikes. And if the field was running around the magnet, it would make spikes sticking out in the end, right? Because it's not going around, it's just going straight up. So when I mean a magnet is like it's like a brush. I can stretch the field of that magnet, those hair coming out, those spikes coming out of that magnet. I can stretch it with G-force. G-force, will do that. I mean, you put it into a centrifuge and you spin that, then you have gyro force, which G-force is attended, right? And it will stretch those air as far as whatever speed you're spinning it, and how strong the magnet is. It will stretch that like elastic. But as soon as you slow down, they come right back close to the magnet. So therefore the field is not really moving. We can stretch it, right? We can manipulate, we can change the angle on it, but it's not moving. It's not a live field. It doesn't have any action, right? And so we all figure out magnetic field, magnetic radiation and stuff like that. For the last year and a half, I cannot find magnetic radiation. I cannot find magnetic field beside red against a magnet. I find EMF, RF, which now we know is bullshit, is literally a resonance. That's why you have a release of an electric motor. It's you get resonance. You can put another electric motor very close. Now in touching the other motor, and you will pull up 20 to the 30 to 40 volts out of the other motor without the other motor's not turning. It's just sit beside it. Resonance does that, and that's what they have. We have people that are more effective to resonance than other. I know I have a friend, when I run the machine, she goes all kind of funny. She says the whole body tingles because the resonance is more sensitive to resonance than other. It doesn't, it doesn't really affect me. And like, so it's like anything else. I'm not allergic to peanut butter. Other people are allergic to peanut butter. So, but let's go back. I want to show you what this is. You guys all saw this meter. Let's try to. Oops, sorry. There we go. It's a tri-field meter. Everybody saw it, right? Now I'm going to bring it down so you see perfectly. I'm going to put it on a test, right? So I'm going to go to battery test. Let me go back here. 0, that's off, and that's first action is battery test. Battery shows good, no problem. Okay, now magnetic field. Well, we have a tiny bit of magnetic field because I'm going to need light. I got light all around me, so I'm going to back up, and it goes back to. You guys can see that. If you can zoom back on that, it's going to be 0. That's what the thing is marking out, right? Now, this is for a magnetic field. Microwave, electric, right? And I'm picking up from, I got a fluorescent over there and four little twisty bulb, and I'm picking up some of the stuff, right? But when I'm far enough, at that distance, I have 0 on the reading. And I get a magnet stuck to it. So, now I want to show you something. If I take that, I want to make sure you see, right? Nothing's happening, right? The machine is off, right? Nothing's happening, so we're not making the thing moving from one thing to the other, right? Nothing is happening. Now, I'm going to turn it on. Okay? Now, is at 0 to 100 range, right? And watch that. Oh, a lot of magnetic field. Look at that, right? Really, a lot of magnetic field, right? Look at that. The magnet is on it, and he went back to 0. That's mean that field is not alive. Now, there again, people won't believe me, right? But it's not alive. Okay? It's dead. It doesn't move. Only when the magnet moves. Now I'm making the needle move. So now I'm going to do something. I'm going to reset the camera. So I'm going to show you how the way people see electromagnetic is a total farce. They don't have a clue. I mean, if the electromagnetic field around the planet, I don't really think exists. I can see layers of resonance, because that we can see. But I'm doing tests here. You can't beat me on that test, right? Because I'm going to show you something. If the field is alive, I'm going to put a magnet on each side of the box, and then I can move the magnet with the other one from one side, so the field goes right through the instrument. And then I will stop moving it, and the instrument will go back to 0. So let me reset the camera. I'll be back in a minute. Alright, I'm back. Now you can see the equipment is still at 0 to 100 range, which is the maximum range. And of course you're going to see the needle is moving, right? As I'm moving, I drop the magnet, nothing happened. Now I'm going to go with the other guy here, which is the ball magnet. And now we have reaction, right? We have reaction, right? So I mean, like, because the field is really strong now. Now, the field is going right through the meter. Now, as you see, now I activate it as resonance, because now when I'm talking, you will see the needle go up, 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 up. It must be a certain, is my low tone. So as I'm speaking, the needle is moving. Now,
I won't speak anymore. Needle's not moving anymore. Okay. Now it goes right through. So I can move the other magnet. There we go. So I'm moving the other magnet. So the field goes right through the instrument. And nothing is going on. That field is dead. Except the resonance. Now, here's the instrument, how it works. We'll put the magnet away. Okay. And watch that. Just going to take tiny little, whatever, hard to scratch. Well, first thing, look at that. Oh, sorry. I'm not working with magnet now. I'm going to go to 0 to 3 range. Okay. And I'm just going to scratch on the side of the box. Okay. I didn't build this instrument. The scientific world built the goddamn thing. Okay. Now, if any scientist can tell me why a magnet don't have a live field, that would be interesting. I'm just going to reset this camera here. Give me a second. So, this was just a little demonstration what a magnet is. You know, and when you realize, and it took me a little while. I mean, that didn't happen overnight. You know, this thing question, and I got other instrument, which the digital, but they won't pick that up because they work. But this thing here is analog. It doesn't fail. That's like it's just like a brick. You know, it's nothing to fail in there. So if it would be picking up any type of electromagnetic field, will actually move. And you don't have to move fast. I mean, like if it was moving it, I mean, a micro of an inch per second, I would be able to read it. But it doesn't. It doesn't move at all. You know, it's a total, it's like I say, it's just like a wire brush. You know, when you have a wire brush standing on his back and you see all the hair sticking out there, you know, you don't. So, as I was explaining, the feel, you know, sorry I got interrupted there. So, but all the explanation I've been, you know, talking about, matter of fact, I was just talking to a gentleman, that was the phone call. We're talking about what's going on and stuff like this, you know, from the States, but, you know, I want people to understand and you know, how electromagnetic really do not work or do not show the way the world of science say it is. You know, all you gotta do is go buy yourself a tri-field. You know, they're like $200 and some. Go buy yourself one of those and then do your own tests. I mean, like, you know, you don't have to you know, to be you know, anything, you know, I just don't, I can't find the word anymore, because, you know, when you do the tests with magnet and the instrument, right away you will see, you know, it's no live field around that magnet. It's just a bunch of hair sticking out, you know. And when I say, you know, a magnet, when I use them for my generator, those long fingers, they're just like guitar pick brushing against the coil. And there's no iron in the coil, there's just a coil, just an aluminum coil. So if I'm producing enough of those friction, suddenly I'm producing a hertz, and then suddenly volt shows up because it's in the coil, it's copper coil, right? It convert everything up. I mean, like, you know, look, you shove a bunch of copper wire up in the air, you know, and you can pick up volts with a voltmeter, because the coppers, you know, the way it works, it convert the resonance and it carry the hertz and turn everything into volts. Then and the hertz show up in volts. So
You know, it's pretty simple. Just walk underneath with your voltmeter, a regular voltmeter, and just put a little stick of a little antenna about this long of copper and one clamp, and just walk underneath the power line and just let the other wire just dangle. It doesn't have to be nothing attached to it, and you will see you're picking up volts. Well, you didn't see any volt coming out from that piece of copper to the power line, because there's no volt coming out. It's all in the volume of resonance. What you're seeing is the amount of volt you got is the amount of volume of resonance that little piece of wire picked up and converted to whatever volt it is. But the hertz will always be the same. It won't. It doesn't matter how long the wire is and how short, how big, how fat. You know, it makes no difference. The hertz will always going to be there, right? Because you didn't remove it. You didn't use the hertz. You know, that's all an instrument going around. You know, it used the hertz, but it didn't use anything else. So if you do your own test, just order one of those. Find yourself a couple of magnets, right? And then you'll find out how things work. And then people won't have any bitching about it, you know. Do your own bloody work. Don't let people do the work for you unless, you know, you're couch potatoes, right? So, I mean, like, you know, and I have a message for somebody. I mean, I don't mind being bitch hot, you know, but at least learn how to spell my fucking name, you know, because you could insult the neighbor and then he'll be mad at me. So, yeah, just get yourself one of those and a couple of magnets, you know, and do your own little experiment. And let me know if you find a flowing feel of magnetism anywhere now after you do your little test. It's none. All this instrument I got, you know, I got a handful of instrument, and, you know, they're lying. Not because it's their fault, but it's because of the prick who manufactured that for the big corporation. That's why they're lying to you. So make your own tests, you know, and then bitch, you know, then make a video and show me your test, and then bitch, you know, you can bitch slap me if you want. But, you know, if you have something to show me on a video. But beside that, you know, keep your mouth shut if you can't do that, because you only a click, right? So yeah, well, that's about it. So hopefully that will kind of inspire you doing your own stuff. Very simple little test. It doesn't cost a fortune there. You can even find somebody who's got one of those, right, without buying it, and you will find out right away. You know, there's no motion around a magnet. So there you go, folks. So I'll probably put that video as soon as I can, because I want to try to explain people how I see things now. Because by knowing that, and if you really think, you know, it's no motion and stuff like this, then you're going to start looking at things, and now you know it's not working that way. So that's the first start. Learn how a magnet really works, you know, and how you can, you know, do stuff with a magnet. So, all right, guys, you guys have fun with that Luke project, and let me know on my YouTube. Just give me some comment, whatever, you know, whatever you try, let me know. It's a pleasure for me to watching other people at least testing the stuff and say, wow, it's different. You know, we didn't know that was going to come out of that. So there you go. We'll catch you another time, guys. Bye. Hi. I just made a video today, but I forgot I want to put something else in the video. I want to show you something is kind of quite unique, and it's from this little machine here. What I'm going to do is I'm going to run the machine, and I'm going to, of course, see it's just a loop connected to the machine. And what I'm going to do, I'm going to disconnect one part of the loop. I'm going to put another wire into it, and I'm just going to put that coil on the side there, and I'm going to take the same wire and bend it around itself, and I'm going to bring it back to the source of the power, and that wire will have more volt than what I'm pushing in, and it will be pushing volt back into the system. So I'm just going to set it up. So I'm going to turn the camera off for a little bit, and I'm going to reset it up so you can see exactly what I'm doing, and you're going to be able to see the spark. So I'll make sure you got a good vision of the spark.
and just so people can look at it, and it's, you know, it's just a straight loop of wire, and it comes right back and spark on its own. So when it comes to the laws of energy conservation and all that stuff, it blows the door to all that, because that's not supposed to happen. So if you gave me a couple of minutes, I will reset and I will do the experiment so you can have a good view of what's happening. All right, so I'm reset, and of course I brought the focus really tight, so I'm going to back up the focus a bit so you can see a little bit more here what I have. And all I have is tied up, you know, from the output of the spark gap, and it's just the end of the cable. I just disconnected it from the coil. Here's the connection, right? So I just took a voltmeter connection and connected back to the end. So now the source of power goes through the spark gap and into this wire here. So now I'm going to just run the machine, and you will be able to see the spark coming out of the unit. So you'll be able to see everything, you know, how the power goes through the spark gap, through this wire here, and back to the spark gap, to the beginning of the spark gap, and I'm shooting about 1/4 of an inch plus spark into the system. So that's mean I'm getting more volt on the other end of the spark gap than what I'm putting into the spark gap. So let's check that out. Right? So I'm just gonna resume it nice and tight so you guys can really see it. Back up a little bit. Alright, so let's start that up. Now, I mean, can you see you can see the spark shooting back into the system. Right now I'm putting out over 1/4 of an inch at a V spark right now. I'm splitting the spark in two. Now, I'm going to do it with less light and see what happens. I'm going to turn some light off here and to see if we can get a better view of the spark. Oh, that's pretty good. So let's see that now. We're a bit more in the dark, so I want to make sure you guys really see the spark coming out of that wire. Look at that. Now, is anybody can really tell me why suddenly I'm making more volt in the end of the wire than what I'm putting in? And I have a very good explanation. If any physicists or scientists who would like to jump in and try to explain that, I can do that all day long. So let me put everything away. I'm going to reset, and then we'll chat for a second or two. I'll be right back. All right, so we're back with the light. So as you can see, right, that was the whole unit, and as you can tell, it's tied up. That wire is tied up to the end of the spark gap. Now, why do I have more power in the end of this line than what I'm putting in this line going through the spark gap? Well, my explanation is a lot of people will jump right away into the heater, right? To the vacuum, to dark matter. But I don't think it's quite, I don't believe, you know, personally, I'm doing the experiment, I'm doing the test, and it's not the way they think it is, because when someone's going to throw dark matter to me, I'm going to say, okay, here's my shop, you come here and you show me dark matter. You know, if you know how to make it, if you know how it's made, if you have the recipe, you're going to have to come and show it to me. You be beside me, and if you cannot make the unit, I'll make it and we'll test it. You know, but you will find out it works in a whole different way. So what's happening is, when you have a spark gap, I mean, you know, we're looking about you know, that one's got about almost 3/16 of an inch gap. That one's got 1/16 of an inch gap. Well, when the energy which come through the system, through the bulb, right? Because now when you go through the bulb, it turns itself into
a radio wave or a radio high frequency RF, if you want to call it, right? So it goes into the bulb from the bottom, goes all the way up to the top, comes back from that rod there, comes into that wire, goes right here into my spur gap. So anything would jump at high voltage, high resonance. It's called that point A to point B. So you have time equation and space. That's two elements, time and space. Now, what I'm doing through here is I'm literally manufacturing electrons. This guy here put out electrons. And because I got iron into the system, like, you know, the coil has got an iron core and the magnets spin between the iron core, so I'm fabricating fresh electrons, non-polluted electrons, or not contaminated electrons. And what's happening is when they go through the first jump, they go into time and space. Well, those electrons, they're already energized. That's mean they're primed with energy. So when they go into time and space, what's happening is they're going to into a stage where is tons of other electrons, but because those ones are activated, they're just like a magnet with ion filing. They gather and they jump on that electron. They make, you know, and then you have a stack of electron or a lump of electrons. So the time part is the distance, the time, the nanosecond it takes for that jump to go over. So he goes off point A, n times, through space, pick up more electrons, and come back and point B. So now you made the jump. But when you reach point B, is a lot more electron or energy on B than it was in A. And that's because it's going and it's getting something from space, time and space. And time and space, it doesn't have to be out in space here. Time and space is around you. We're living in time and space. So that's the reason when he does that a second time, you can do it 3 times. The maximum spark gap, you can do 3 spark gap. And they all multiply, you know, and they look like they don't have much power in the end. But is actually the power is more power, more potential into it than the beginning when they start. And this is, you know, as far as and I did this experiment hundreds of times in random of logic, what can happen, and I, you know, I mean, if you say it's heater, then you're gonna have to prove it to me. Now I'm proving you a physical test, not bullshit. Physical test and the physical result of manufacturing energy and the same wire of the energy come from. So and it's not a lie, it's not a joke, it's not Houdini, it's right there. If anybody want to come and see that, then all you got to do is contact me and you can come here and see it in person. And you can record it, you can video it and stuff like this. That's how it works. So energy is, we can tap in some energy and free energy. You know, it's just a question of how you manipulate the element around you. And you will be able to release energy, you will be able to tap, you will be able to gather energy, you will be able to, you know, separate. I mean, you know, as I explained in the last video, is, you know, everything is about gravities. Now, when we're talking about gravities, we're not talking about anti-gravities, which is part of what we're working with, but not what I'm doing. What I'm doing is I'm using different type of pressure to create a different type of gravity on my bench. Now, you know, it's just a small version of what I'm doing because, hey, I don't have a big lab. I'm working in a shoebox. So, but the tests are tests. It doesn't matter what size shoebox you're working in. The proof and the test is in the pudding. And that's what I like to find out. If it's anybody, you know, scientific field, whatever, you know, bring him on. I have no problem with it. Bring him on, right? It's just simple. I mean, like, you know, all my stuff when I talk is because I tested and did it over and over and over and over. I'm not just talking out of my ass like most people does, right? I can show you proof. I can show you everybody who came to my place and I show what all my unit does. They walk out of here as how the hell it does that, right? They're all in ahs and and they can't believe what they see. Well, I mean, I can believe it or not. The fact is a fact, right? So here you go, and that's we'll tie it up with that little video I did earlier, and you know, hopefully that will be to help to some people to understand energy is all around you. It's just a question of how you manipulate and how you tap into it, and how nice you are to it for that energy to be able to work with you. You know, you can't force it. It's part of nature. You know, that's why we living in a sea of energy. We just have to be nice and ask nicely, and they will do stuff. I mean, I call that, this is the voodoo machine. It does all kinds of trick, you know. So I mean, to the point you see, you can take picture with a proper camera of other entity around you when you run this machine. And I believe me, I took picture of them, so I have picture of them. And I showed up to people. Everybody comes in, doesn't believe me. I pull my laptop up and I show them the picture, and they go, "Holy shit!" Right? Because they're not pretty looking. So here we go. So if you want to scare the crap out of yourself, build yourself a machine, and have a party with some identity. You know, they're not that. They look terrible, but they don't do anything to you because we're not working in the same resonance. They're all around us. I can detect them now. I can read it because they leak of millivolts when they walk by you, when they pass by you. They have, you can feel, you know, for a split second the millivolt will go up and the sensor and drop down just as someone walked by you. And some of the big, they have more millivolt. Some that are smaller, they have smaller millivolt, because volt is volume. So whatever size beings walking around, you can pick them up in millivolt. And that's why, you know, Ghostbuster machine for finding ghosts and stuff like this, you know, they carry, all you have to do is having something you can, you know, read millivolt or nanovolt, and you will be able to pick up anything passed by you. So there again, you know, we are on the left field again, but hey, that's the kind of research I am and I'm doing, is pretty much always in the left field. So hopefully you enjoyed this little demonstration, and hopefully, you know, you'll be able to see it properly. I'm pretty sure you'll be able to resume on that, and let's see how that turned out, and hopefully you enjoyed the video. So we'll catch you. I think I have more video coming out because everybody's asking me to explain one thing at a time instead piling all that up into one video. So that's what I did a video earlier, you know, and then I'm doing this one. So, you know, we can compile that together, and we'll be able to have some kind of idea what I'm doing. And believe me, I'm not the only crazy person doing kind of stuff like this. I have another crazy person in Toronto, Mark, and this guy is just as bad as I am, but he's working with something which I've been working with, and he's been proving everything I've been saying and more. So when it comes to induction, which is not the proper wording for it, but we'll work with that for now, and transfer of energy from one side of the house to the other, you know, charging battery, wireless charging battery, you know, you name it, it doesn't matter, you know, we can do that. It's not, that's not a problem anymore. It's not an issue. So yeah, so let's move on, and I hope you enjoyed this video, and hopefully I will make more video of different, you know, to redo all the tests one by one. And soon I receive back my equipment, then I'll be able to continue my tests and do some video and let people know it's not a trick, it's not nothing, like this thing is actually working. So and then by the time we get all our parts and everything up, we'll be able to do a test with the generator, the slasher, into the transformer, and we'll be able to see exactly what's putting out of that. So in the meantime, hopefully you guys have a good time watching the video and enjoy it, and we'll see you later. Hi, it's me again, because I forgot. I want to make sure I show in that same video a few little things about, you know, what I've been explaining about, you know, resonance and multiplication of the of the power through the spark gap and stuff like this, but it's all done literally, you know, literally by resonance, and it is a function. So I got a thing all set up here, and I'm going to show you how, you know, you can create, you know, how literally how a motor works, you know, or the generator works for an RF motor to be able to produce millivolt out of it, and it's all about resonance. So I'm going to reset the camera here so you guys have a good view, you can see the meter and all that, and I will create millivolt just by tapping on the iron with a coil. It's just a part of my pump. I'm just tapping on the top, and you will see millivolt. You can achieve all the way up to 200 millivolt just tapping on it. So I will reset the whole thing, and you guys can take a look at it. Now, as you see, is I got the thing set up here, so you see the meter is all zeroed in. It's on the AC volt, which is an oscillating. I get part of my pump, which is just the coil and the iron. You know, and that one has got aluminum wire. It doesn't make, you know, difference, copper. I mean, that one make a little bit more power because aluminum, you know, produce a little bit more. So let's see how much volt, how many millivolt I can produce though. So here we go. I'm just not, and it's just an old file with a wooden handle, tin file. Yeah, 300 and some millivolt. Not bad, huh? You get a good exercise for your arm, and you get some volt at the same time. So that's how you make energy with resonance. All I'm doing is tapping and making the molecule of the iron resonate inside this coil, and obviously you got volt coming out, and that's exactly what a magnet does. It just creates a resonance inside the iron, and the iron do the job, you know, to transfer the resonance into a wire, like I explained before, and a certain amount of wire will have a certain amount of hertz. Now I'm not too sure. Let's see if I can get hertz. Use a lot of volt to check the hertz, so I'm not too sure how that's going to work, but let's try it just for the heck of it. Okay, so 0 hertz. Let's go for it. Yeah, see, I need more. Oh, 10 hertz. There we go, 10.7 hertz. So there we go. We have hertz coming out from resonance. We have volt coming out from resonance. We have everything coming out from resonance. So there you go, folks. I hope you enjoyed the demonstration. So another little puzzle for all the scientists to tell me about how that works. Catch you later. Bye.